So this is research on digital innovation, really. And the way we define digital innovation is the incorporation of increasingly digital content, if you want, to material artifacts as we know them. And so the car is a great example of something that's become increasingly digital. We have more and more sensors in all aspects of the car. The engine, the tires. You can now basically get an indicator of low tire pressure, on your dashboard, essentially on your instrument cluster. And so what we thought was very interesting about the instrument cluster in particular, in terms of this overall, movement in terms of the car becoming more digital, is that the instrument cluster makes the digitalization of the car very visible to the, driver. And so what's happened is that, the instrument cluster has really become a point of differentiation amongst car manufacturers. There's increasing emphasis on the dashboard, the driver information module, as it's called, and sort of also the center stack, right? The features, the functions that you can get, in that instrument cluster. And so, in terms of tracking digital innovation and understanding the process of digital innovation, which is really what we were interested in, this was a great opportunity, not only because car companies are focusing on it, but also because it really is making the entire digitalization of the car much more apparent. And so again, car companies are under quite a bit of pressure to get these dashboards, to improve these dashboards, and essentially make them more digital because of consumer electronics, right? So all of us are running around with our phones these days, and we have tablet PCs and increasingly feel like we can essentially choose what kind of apps we are running on these devices. And so again, consumers are saying, why can't I have that in my car, right? Why can't I choose apps in my car? Why can't I choose the navigation package, that I want, at a click of a button, essentially. I want to have the Google, apps navigation service, essentially, right, in my car. That's my favorite application, and so I want that rather than what the car might come with, or a whole host of other options. And so this is essentially the movement in the car industry, and we were particularly interested in understanding the process of going from an instrument cluster that looks very traditional, where you have sort of dials, and those dials are essentially, very constrained through their materiality, right? If you think about a classic DIM or a driver information module, you typically would have two dials, one the speedometer, one the tachometer, and essentially it's got, they've got these indicators for the measurements, right, permanently set in there. And so if you now wanted to add, let's say, a display for time, on your instrument cluster, well, you'd have to insert another dial or another display, a physical display into that instrument cluster. And what is happening now with digital, sort of with the digitization of the instrument cluster, is it becomes simply a screen, the same way your iPhone, or your mobile phone is a screen, or your tablet is a screen, and what you display on it depends on, what application you essentially call up. And so what is happening in the digitization of the instrument cluster is that we can now essentially reprogram and customize, what it looks like, what your experience of that dashboard looks like. And so if you're, let's say, a driver that's very concerned about the environmental impact of your driving, you might basically have displays related to emissions, emissions. You'd want to see those, or you might have displays related to the gallons, miles per gallon, sort of the gas mileage that you get, right? That as sort of central displays as you're driving, versus somebody who's very interested in speed and wants to know, well, how many more revs can I get out of this car, right? So essentially, you'd have a display. You could customize the display to essentially show the revs, for example, or how much more power you can get out of this car. And so that is sort of what is happening in the digitalization space. And so we certainly thought that was very exciting in terms of seeing the evolution. And so that was, what we were interested in, essentially. What does this then mean, though, for car companies? What does this mean in terms of actually incorporating increasing digital content into, the car? And it's actually, quite difficult for car manufacturers to incorporate, the logic of software, which is obviously what's required when you're talking about, digital innovation and making the car increasingly, intelligent, which is really what's happening. Because one of the things we know about car companies is that they design their cars, years in advance before they actually go into production, because it takes, even once you've got the design set, it takes quite a bit of time to negotiate, with your suppliers to manufacture those particular pieces, to make sure that those components that your suppliers are producing, are the right ones, or really do fit, that they really fit with the other components that, that you need in your various sub-assemblies and so on. And so there's usually a substantial, time lag between the design and then the actual, manufacture. Well, that logic is very different in software. That one of the things that the software industry has learned is that you don't want a long time lag between, deciding what the product needs to do and then, implementing it. Instead, what the software industry has learned is that you want to prototype, and essentially, finalize your product just before you go live, so that you essentially meet the requirements of the day, not the requirements of a year ago. Right? And so if you now bring those two things together, the traditional car industry in terms of the material components and how long it takes, to essentially get them manufactured, and then the flexibility of the software industry, right? Those two things, the one takes at least a year from final design to manufacture, and or sort of go live if you want, and the other basically says, we don't want to go live way ahead of time, right? We want to sort of a just-in-time kind of solution. Those two things don't blend all that well. And so basically there are quite a number of tensions, between sort of the manufacturing side, where you're dealing with material components, and the digital side, the software side, right? Where you're dealing with digital components, which are much more flexible, much more adaptable, right? Where you can basically reprogram devices, and basically get very different functionality out of, sort of various devices through software design. So essentially the car company that we studied is a real company, right? And these projects are very much real. The only thing we had to do was essentially give it a pseudonym, largely because the very last project that we looked at, which is called the Platform Project, which essentially is an attempt to turn the the DIM into a kind of platform that we know sort of from the internet sort of internet business model, if you want, where, for example, I would be able to download the app that I want, right, into the car. So that's sort of the last project we looked at, and that hasn't gone live yet. And so they wanted to keep some of the details under wraps, and therefore we couldn't use the company name. So it's an absolutely real company, and certainly I think the main implications of the research is is that what companies need to recognize is that they have typically, sort of in the manufacturing side, they have typically organized in verticals, right? So there's what we call sort of a modular architecture. So they have organized, sort of the engine group, right? And then there's a steering group, and then there might be a chassis group, and so on. And so, the organization has typically been very much along vertical lines. But in the software industry, we have organized in layers, right? With a device layer at the bottom, and then increasing layers of abstraction, right, to the application layer at the top. And that's how the internet is organized, and that is what allows us to essentially use different devices for example, a mobile device, a tablet, products that run sort of an Apple operating system versus a Windows operating system versus an open source Linux kind of operating system, right? It doesn't matter what device you bring and what operating system is running on it, you essentially can connect to the internet, download a website, download an app, right? Get applications. And so this is all based on a layered architecture. And so this layered architecture is somewhat at odds with a sort of an organization that is layered and more horizontal, if you want, is at odds with a more vertical organization. And so one of the things that the paper identifies is that these two are orthogonal to each other, right? And so you need to connect this vertical organization with this layered organization, and so one of the things that then comes up is obviously how do you do this organizationally, so one of the things certainly that Auto Inc. did was they increasingly gave decision-making power to the HMI group, so the Human Machine Interface Design Group, right? So they became increasingly independent, and they set up teams, what they call feature teams, that were headed by people from the HMI group, so that these feature teams essentially got the right people from the vertical organization and connected them to the layered organization that was more on the software side. So ultimately it has implications for how you organize. A key piece of what our research was showing is that as you're developing, as you're becoming more digitalized, right, as you're doing more digital innovation, a key component is actually identifying the layer, sort of the boundaries between the layers, or the interfaces between the various layers of the software architecture, essentially. And those are not always easy to identify, establishing where the protocols need to be, what kind of protocols, what kind of boundaries that are neat and clean, right, where they need to be and how they need to be operationalized. That's not always easy. And so one of the lessons was that the Auto Inc. essentially used software from, to develop its user interface from the software industry. And that had built in already its own layers, right? So essentially, what this also sort of says is that you can inherit, right, architectures and layers from other industries, for example, the software industry, right, to basically get you further along, as opposed to home growing, your entire sort of architecture, right? Sort of to learn from others and to incorporate lessons from others by using software, for example.
Do you think that there are lessons here that can apply to other industries, or do you think that this is really kind of more unique to the auto industry because of the way that it is traditionally operated its dashboard?
I actually think it's applicable to all industries that are moving to what we call the Internet of Things, right? So increasingly, chairs, devices, all kinds of devices are connected to the internet. So people are talking about the intelligent home, where you essentially have microwaves and fridges and water heaters heaters and, thermostats. Everything is connected. Everything is intelligent, has sensors in it, can sense what is going on outside of itself as well as what is going on inside, generate data, have that data analyzed, use that feedback in order to adjust operations that are going on in the water heater, in the heating of the home, whatever it might be. And so actually, in all of those companies that produce those material things, right, I think are increasingly going to be under pressure to make those things digital. And so I would say that, as we're moving to the Internet of Things, as there's more demand that, we have intelligent devices that we can, connect to, communicate with, on an ongoing basis, essentially most manufacturers of material objects, I think, are going to be faced with similar issues. Because, the organization, the vertical organization that I talked about in the car industry is not something that is unique to the car industry. I mean, in theory, we talk about it in terms of the product isomorphism, right? So that essentially you organize in the way that your product is organized, right? And so essentially, even if you're a fridge manufacturer, they're going to be, along product sort of components, right? You're likely to be organized along component lines in vertical kinds of ways. And so this much more layered logic of software is not something that is necessarily, a natural fit for you. So I think actually most, especially mature manufacturers, are going to be confronted with these very things that we studied in this paper.